All right, class, I'm now going to start at number 19, and my goal here is to make sure I get this all done here in 15 minutes. So let's get started here. An object has an acceleration of 5 meters per second squared. What does that mean? It means that every 1 second, its speed or velocity increases by 5 meters per second. So it's like every second, an object's speed goes to 5. Another second goes to 10, another second goes to 20. It does not mean that every second it goes 5 meters. That would be a constant speed. It's a very common mistake. Question number 20, this is a velocity versus time graph, very important. This is a v versus t graph. Which time intervals is the object at rest? Well, there's really no time intervals in this graph. It's only 2 actual points when the object is at rest, and that's when it crosses the x-axis. So that's right there at t equals 4, and right there at 16, 17, 18, t equals 18 seconds. It's a little misleading that it says intervals, but they might do that on the AP test. During which intervals is the object increasing its velocity, magnitude of velocity? Basically, when is the object getting faster, either in the positive or negative direction? That's going to have to be here from t equals 4 to t equals 9. So t equals 4 to t equals 9 seconds is 1. Then it slows down, then it's constant speed, then it slows down again, and then right here it's going to go in the positive direction and it's going to speed up. So that would make it t equals 18 to t equals 20 seconds. Next question is a very difficult question. It's basically saying at some time, at time equals 0, it's located at x equals 2 meters. Basically it means it's got a 2 meter head start on something else that we don't know about. We want to know the position of it at 9 seconds. Well, what I did was I said, all right, it's a velocity versus time graph. I can figure out where it went here by figuring out that area, which I found that area to be 1.6 meters, positive 1.6 meters. And then I found the area here from t equals 4 to t equals 9. I found that area, and I found that that's in the opposite direction, so negative 2.5 meters. So basically, the object went 1.6 meters forward positive, then it went the opposite direction 2.5 meters, and what I got from that was negative 0.9 meters is what it did in those first 9 seconds. But if it started at the 2 meter mark, so I have positive 2 meters minus the 0.9 meters that it went, we get positive 1.1 meters. Sketch the acceleration versus time graph below. So that's just the slopes. Okay, so you just have to find the slope of the graph above. So it looks like it's negative 2. Just kind of skipping just to save some time. You just have to find the slope. It's negative 2, and then it becomes positive 2 from 9 to 12. Right there. Then the slope becomes 0 all the way until the 17-second mark, right there. And then it has a slope of positive 0.4 meters per second. So that goes on until the 20-second mark, and then the object stops for the last 5 seconds. I would just make sure you look above and make sure everything lines up correctly. So you have a negative slope, then a positive slope, then 0 slope, then positive slope, and then 0 slope. And again, the weird thing is that even though in this interval here, all the way in the first 9 seconds, it's going positive direction and slowing down, and negative direction speeding up, it doesn't matter. The slope right here is the same. The acceleration is the same the whole time. The fact that it's changing directions does not affect it at all. All right, we move along. Question number 21. We want to see a runner accelerates from rest for 2 seconds in a 100-meter race. The last 90 meters are run at a constant speed. Determine their acceleration for the first 2 seconds. Okay. Well, you'd write out your givens. VO is 0, time is 2, delta x is 100 meters minus the 90 meters that are run at a constant speed, so they're accelerating for 10 meters. And then I would just use delta x equals v naught t plus 1/2 at squared. To save some time, you should go through it and you would find that the acceleration is 5 meters per second squared. Their instantaneous velocity at t equals 2 seconds is basically their top speed. So their velocity equals initial plus a times t. So their initial velocity is 0, their acceleration is 5, their time is 2. So they get an instantaneous and max speed of 10 meters per second. The total time they're on the 100 meters, well, this is going to be to solve for the time of constant speed. So, I mean, you could do this if you want, plus 1/2 at squared, but at the end there's no acceleration. So this, what I'm left with here, delta x equals v times t. We don't even need this VO because it's constant. That's basically our constant speed formula. So if they got to go 90 meters at a constant speed and they're traveling at 10 meters per second, which is what we discovered above, then we would solve for time, and their time is equal to 9 seconds. Well, the whole 100 meters, well, we have 9 seconds at a constant speed, plus we have the 2 seconds that it says to accelerate. So we get 11.0 total seconds. It says draw a displacement or distance versus time graph. Well, what I did was I was like, all right, so for 2 seconds, they're going to accelerate. And we know they accelerate for the first 10 meters. So I went, all right, so they're going to start here at 0, and in 2 seconds, they're going to go right here to 10 meters. So I made that a nice curve like that. And then the rest of the way is just constant speed, and they're going 10 meters per second every second. So every second, you just go up by 10, which happens to be every block like that. So I just connected the lines as best I could. Almost done here. All right, so we've got an object going from 10 to 40 meters per second in 5 seconds. Determine how far it goes. Actually, I didn't make the directions so great. I meant to have you find the displacement or the distance and then determine its acceleration, so let's do both here. This object travels a certain distance, so I have to shade all the way down to the x-axis, which means I have 2 shapes here. Now you could obviously do this with a formula, and actually might be easier for this one, but I'll go ahead and use the shading. So for this one would be 1/2 base times height, so it'd be 1/2, my base is 5, my height is not 40 because it starts at 10, my height is actually 30, and then the green base is base times height, so the base is 5 seconds, and the height of that is 10, so I get let's see here, let me go to my calculator. 0.5 times 5 times 30, so we get 75. And this we get 50, so that's 125 meters total. The acceleration should be the slope, and the slope is rise over run, so it rose 30 because it went from 10 to 40 and it ran 5 seconds, so that would be an acceleration of positive 6 meters per second squared. Okay, almost done here. Problem number 23, we are going from an acceleration versus time graph to a velocity versus time graph. We are working our way backwards. What you should know is that these are the slopes of the velocity versus time graph. So I just have to have a velocity versus time graph with the slopes that I see there. So I need to have a slope of 1. So for me, I just did this. I just was like, all right, I'll start at 0, 0. I'll go over 5, up 5. And that would give me a slope of 1, which is why I have an acceleration or a slope of 1 right there. And then I want a slope of 0, so I just went straight across. What makes this problem actually kind of tough is like that acceleration graph doesn't tell you what your initial velocity was or your final velocity was. You don't know. You just know that it represents how much the speed is changing, which means you could have something that looks like that and like that. Heck, you could have something that goes like this and like that and actually changes direction. So I just needed that shape with that, correct slope of 1 and then a slope of 0. So it was actually kind of tougher question right there. It says, what could the object be doing from t equals 0 to t equals 5 seconds? Circle all answers that apply. Well, like I just said, you could be going forward and speeding up, so that's A. Heck, you could be down there on the bottom half of the graph with a positive 1 slope. So that would mean you are going in the negative direction and you are slowing down. So you are changing speeds because you have an acceleration, which means it's A or B. You just can't have a at rest or constant speed. And then it says, what could it be doing from t equals 5 to t equals 10 seconds? Well, some people might say, well, it's got no acceleration, so that means it's not moving. But you can have no acceleration and be traveling at a constant speed. So just like in the red line that I have up here, I'm speeding up and maintaining a speed, while down here I'm slowing down and then I'm stopping, which means for the last part, it could be both C or D. All right, I hope that was helpful. If you have any questions, let me know. Thank you very much.